Hello, this is Alex Zaman, and today I wanted to investigate Dropbox's cloud storage service and its core API functionality. I intend to review Dropbox's service, particularly in comparison with Amazon's S3 service, and then to show you how I produced a script using what we learned to transfer files between Dropbox and S3. So let's begin. What is Dropbox? I'm pretty confident that if you're familiar enough with computers to know what an API is, you're probably already familiar with Dropbox. Dropbox is a cloud service oriented towards the consumer market. It's extremely popular and is on a significant number of computers and mobile devices used mostly to synchronize between systems. For example, on my mobile phone, I have Dropbox installed. Whenever I take a picture, Dropbox automatically uploads this file to my Camera Uploads folder. In turn, if my laptop is on, Dropbox automatically syncs the folder and downloads the picture to my laptop. You could imagine my excitement when I realized that this was possible and I didn't need to go hunt down a USB cord and sift through Android's file system to transfer my pictures. Another great feature of Dropbox is that it has a simple but powerful RESTful API. Today we're going to investigate their main API service, known as the Core API. Their API services are rather nascent, but they are rapidly evolving. Just recently, for example, they released a new API service called the Data Store API. This service arose because they basically saw that many people were using their Core API to save and load cloud-based application data in synchronized SQLite files or something similar. The Data Store API can be used similar to a NoSQL database where objects can be inserted, removed, and queried from a data store table. Long story short, you'll likely see a lot of changes and improvements in the near future. Dropbox and S3 have a lot in common. They are, after all, two ways in which files can be stored on the cloud. However, Dropbox and S3 have a number of notable differences. S3 is basically designed as an enterprise-level solution. It has better support for hosting static web pages and sharing content with specific permission control. It has a lot of enterprise-level features such as access control, encryption, and logging, which is not readily available in Dropbox. Most importantly, though, S3 is designed to work with the whole Amazon Web Services cloud infrastructure. Thus, if you're doing something like hosting EBS volumes, mounting or unmounting them, hosting snapshots or images, Dropbox is just not a viable option. Moreover, files in S3 can be transferred to other Amazon services in the same availability zone much more quickly because they're on the same local network. That said, Dropbox has a few advantages up its sleeve. For one, it's consumer-oriented and is thus much more readily accessible to the public. It's a simple interface, and its desktop and mobile application makes synchronization significantly easier to manage than S3. However, the most important difference between Dropbox and its peers is that files re-uploaded to Dropbox, even if they were uploaded by a different user, get uploaded significantly faster than if the same operation were done on S3. In the chart that you see here, the article writer uploaded an MP3 file 5 times to a variety of services. Unlike the other services, all the re-uploads to Dropbox resulted in upload times that took a tiny fraction of the time. This great feature is due to a proprietary mechanism in Dropbox That's called deduplication. Dropbox's deduplication algorithm looks at the file hash and some other information before uploading. It then uploads only the information where the hashes are new. For an individual user, this is not so great. After all, there are only so many times I'd want to download that same Nicki Minaj remix over and over again to my Dropbox. However, Dropbox doesn't deduplicate across individual users. It deduplicates across the entire user base. Thus, if I upload that Nicki Minaj remix, everyone else who uploads the same remix will find it to be nearly instantly uploaded. That's powerful stuff. But is it safe and private? The power of deduplication is that it's across Dropbox's entire user base. However, this causes security risks because users' files are not walled across strict permission systems. They are effectively shared, and it's a concern that this hashing algorithm could be manipulated to get other people's files or other tricks that take advantage of this system. Most of this is a theoretical possibility. For example, say that said Nicki Minaj remix was copyrighted material and the RIAA had recently given Congress a huge and wonderful Christmas present. It is possible that the FBI could identify a file hash and then subpoena Dropbox for a list of all the users that had that file hash. Such tactics would not be so nearly as easy or legally appropriate to do on such services such as S3. There have also been services released that have manipulated Dropbox's hashes to make a powerful file sharing network. Dropship is a program that elegantly allows people to share altered JSON files and to use Dropbox and Dropship's interface with the Dropbox API to download files on other people's Dropboxes. Of course, at this point, the user has to create and share the JSON file if they want to share their files. However, theoretically, it may be possible to gain access to unauthorized files through some similar other hack. Regardless of whether you're a speed demon moving files onto Dropbox to take advantage of its transfer rates, or whether I've terrified you into moving all your files off of Dropbox, the API can be helpful in managing this task. Dropbox uses a powerful and simple RESTful API, which allows you to do all the basic file management functions. It also lets you restore files from previous revisions and get a list of changes to your Dropbox using their Delta function. I will just demonstrate the upload and download function on Dropbox with my demo, but many of these other features are worth looking into if making scripts for the service is of interest to you. Along with REST HTTP requests, they have also designed a number of wrapper software development kits in many different languages such as Python, Ruby, and Java. Since the topic of this project is Dropbox, I will not go over S3, but I did want to refresh you on its interface briefly. S3's Python software development kit is called Boto. Boto includes features to manipulate many other Amazon Web Services, but its S3 interface is very similar to the capabilities of Dropbox's. It does, however, provide the ability to manipulate a number of other options, including security settings, virtual private cloud settings, user permissions, and logging. Another interesting difference is that Amazon's SDK does not abstract away the idea of holding the files as a key in a giant mapping. When you use the interface, you have to create key instances and set the path of their key data member. You then use getter and setter functions to upload the file, which are seen as values associated with the keys. Dropbox does a much better job at hiding this and makes it seem like you're working with a POSIX-like file structure. Before I demonstrate my code, I wanted to briefly run through the file structure. I created 3 main Python classes. One that connects to S3, another that connects with Dropbox, and a final one that connects both of the previous 2 classes to transfer files between each of them. The script runs from this connector file. Now let's check out the script and run it. Let's start with the Dropbox connection. After initializing with the constructor, I created a connect method. This connect method uses the access token and provides that session with the access token set to get a Dropbox client object. I use this client object for all my future methods. I created an ls method to list the directory contents. When I transfer folder contents, this method will become useful to determine what files are in that folder. Here in the download file by name method, you can see where I used getFile to get the file object and to return it after I write it to the system. This is a demonstration of the same download but with getFile and metadata. As you can see, I get both a file object, but I also get a metadata object. In this demo, I won't really be using that information, but it's good to know. In the upload file by name object, you could see how I take advantage of Dropbox's putFile method. Since my files are going to be under 150 megabytes, I can use this method, and it's pretty straightforward using one line of code. However, if I wanted to do the same thing with large files, I would have to use a chunked uploader. Here in the commented out section, you can see how I provided a loop to get all the chunks uploaded. This final method is just something to facilitate loading the token file. Next, we'll look at the S3 connection. Similar to Dropbox, I initialize the S3 connection with a constructor, and I have a connect method. This connect method uses my Amazon access key and my Amazon secret key to connect. If I wanted to create a bucket, I could use this create bucket function, and I just wanted to test it out, so I used it. But in general, when you want to find your bucket and select one instead of creating one, you would use get bucket. The list directory ls function is similar to the Dropbox one, and I just list the contents of my bucket. Upload file by name uses Amazon's version of uploading. Basically, you create a key object in the bucket, you set the key parameter, and then you use the setter method to set the value, which is the file. Downloads are similar. Now let's take a look at the connector. In my constructor, you can see how I connected with the S3 connection class and the Dropbox connection class. After I made an object of this, I used connect to connect to them. From this point, I created 4 methods which could be used to transfer files between the 2 systems. The latter 2 transfer individual files, and the former 2 provide a convenience of transferring a whole folder worth of these files. So at this point, I wanted to create an Amazon instance and upload all of this information onto the instance. Then from there, I wanted to run my script and see what happens. So let's go make an instance. So I'm going to use the Amazon Linux AMI 2013 September 2nd, 32-bit. It's going to be a straightforward setup, and I guess I'll give it access to an existing default security group with a lot of permissions. I already have a key pair set up, so I'm going to use that for logging into my instance. So I'm going to wait until this launches. Now that I'm all set up, I connected to the instance using FTP, or SFTP actually. Using SFTP, I created a directory, let's call it CS-90, and I transferred all my project files. This includes the token files. I'm also going to upload the library for Dropbox and Amazon's Boto library. Now I can log in through SSH. So first let's get the public DNS and open up Cygwin. I type in SSH-I with my key, EC2 user at, and the public DNS. I confirm, and I'm in the system. I go into my folder and I see my files. Before continuing, I wanted to show you that my Dropbox is cleared. On the receive end, I'll get rid of any files. And on the send end, these are the files that I want to transfer. It's 5 files. Now let's check the Amazon side. I'll go into my bucket. On the send side, there's 3 files that are to be sent. On the receive side, there's nothing. So, when my script runs, you can tell that it works because we'll receive the files, the 3 files in Amazon, into my Dropbox, and we'll receive the 5 files in Dropbox into my Amazon. So let's test this script. Before actually running the script, I first need to install the libraries for Dropbox and Boto. So let's start with installing the Dropbox library. As the root user, I need to run python setup.py install from the Dropbox folder that I moved over. If everything goes well, you would see the finished processing dependencies and the installed confirmation. Now let's do the same thing with Boto. Again, as a super user, you run python setup install. And you should also see the confirmation here. Now we're all set to run the script. Let's see what happens. To run the script, I run python connector.py. Just before running the script, let me remind you what it does. The bucket is assigned to there's a hole in my bucket, and I already have the token path downloaded previously. I'll create the connection object, and I assign the locations where it's going to be received and sent. These are the locations that I showed you previously. Finally, I'll transfer the contents of the folder from Dropbox to S3 for Dropbox send folder to AWS receive, the S3 folder. Then I'll send the contents from S3 to Dropbox using the AWS send S3 folder to Dropbox's receive folder, which is saves Dropbox receive. Let's run this script. As you can see, the first folder is completed, and the second folder is completed. So the final test is to see our Dropbox and to see AWS. Let's start with Dropbox. In Dropbox, you see the 3 files transferred in the receive folder. Finally, in AWS, you see in the receive folder the files have transferred. This shows that the script has successfully transferred all the information. Thank you for listening to my video. This is S. Alexander Zaman, and this was my presentation on Dropbox and its API interface.